Dividing polynomials. We're going to look at the fourth operation separate from the rest of them because, in a way, you do this completely different than the other ones. However, the way that we are going to approach this is a lot like long division with regular numbers. When you divide a polynomial f of x by a divisor d of x, shown here, you get a quotient, which we're going to call q of x. You get this. However, in many cases, they are not going to divide evenly. The divisor might not actually be a factor of the polynomial, which means that you're going to get a remainder. So if you do get a remainder, that remainder might not be a number, it might be an expression itself. So we're going to call that r of x. And we'll state our answer like this. When we divide the two, we're going to get a quotient plus the remainder over the divisor. That last part's going to indicate that the remainder would have been divided by the divisor if possible. What we don't want to do is completely separate the remainder. We still want to have an expression that overall represents the original function. And a little bit later on, I'm going to demonstrate that in a calculator for you. All right, so the process for dividing polynomials is very systematic. Okay, we have a set routine in how we're going to go through the problem. We're basically going to set the stage by writing this up as long division. You're then going to go through a process of asking yourself a question and then based on that response, producing more things. It will take a little bit of time. I mean, this is based off a long division, so don't expect it to go really fast. Okay, but it is very systematic, and once you get the rhythm to it, that becomes very helpful. So to begin with, like long division, we're going to put our dividend, the number that we're going to be dividing, inside of a box. In this case, it is not a number, but an expression. Okay, that goes in the box. Actually, I didn't give myself enough room here. All right, there we go. In the box, I got to have enough room up here for an answer. Outside the box is going to be your divisor. That'd be the x minus 2. Okay, and you're going to go through a series of questions. Those answers are going to then give you an instruction on what to do. The first question that you're going to ask is, what would I multiply this leading term by to create this leading term? Okay, don't worry about anything else. Just look at leading terms. What do I multiply x by to get x cubed? The answer to that would be x squared. Now that we've identified that number, you're going to multiply it by the x and multiply it by the negative 2. So you're going to get x cubed and negative 2x squared. Okay, you're going to distribute that to each of the terms you have here. And then what you're going to do is subtract this from the original polynomial. So you're going to account for something that you created. My suggestion here would be to use a new color. We're going to set this in parentheses, we're going to draw a line to divide it up, and then we're going to put subtraction out front so we can remove what we've accounted for. Here's where it becomes very critical that you pay attention to things. This negative is going to distribute through, and then we're going to group. My advice is not to actually distribute it, but just to think about what it does. Now, of course, the beginning's just going to cancel. You don't need to mark it out, don't do anything with it. That negative is going to distribute in here, making that a positive 2x squared, which will group with the 5x squared, giving you 7x squared. We're then going to drop down our next term, just like long division. Okay, we're going to drop that down, so we get negative 7x. Okay, we're going to repeat the process now. What would we multiply x by to get 7x squared? That would be 7x, a positive 7x. So then we do that. We multiply. We get 7x squared. But we also multiply here. We get negative 14x. We're going to use parentheses, subtract, separate. This will cancel. We're going to pay attention to this part. Becomes a positive 14x with negative 7x gives you positive 7x. We'll then drop our next term and repeat the process again. What would we multiply x by to get 7x? Positive 7. So now we do that. Plus, multiply here, so we get negative 14. Parentheses, subtract, divide it up, cancels, distribute. you get positive 14 and 2, which gives you 16. Our overall answer is going to look like this. Here's your quotient. The remainder, you're going to take the 16, you're going to place it over the divisor, and just put a plus between them. All right, so what I want to do next is at least demonstrate for this one problem that what we did was correct. Okay, and I'm going to evaluate using a calculator to demonstrate that. All right, what I've already typed in would have been our polynomial divided by the x minus 2. Okay, what was inside the box, what's outside the box. Same thing that we have here, but have it stacked. And when I press enter in the calculator, I do get back a value because currently the calculator believes that x is a certain number. I have a value that's stored in there, and I'll show you what that is in a minute. Okay, what I also have typed in, but I have not evaluated yet, is what I believe the answer to be. Okay, so when I press enter, I should get the same thing. And I do. Okay, the reason that I can do this in the calculator is because the calculator believes x is a certain number. So essentially what I'm doing is evaluating each of the expressions for a certain value, the same value. And that value here is actually 5. So I just happen to store the number 5 in for x. Then I evaluated these and saw that they were the same. Example 2, pretty much the same thing. We're going to start with our dividend. We're going to place it in a box. Divisor goes outside. And we go through the process again. What do we multiply x by to get x cubed? That would be x squared. Okay, so now we do that. X squared times x is x cubed. Also multiply here. We get positive 2x squared. Okay, parentheses, subtract, break it up. These will cancel, that's the intention. This will distribute in, you get negative 2. That is going to be a negative 1, so that gives you negative 3x squared. We're going to drop the next term, positive 4x. Repeat the process. What do we multiply x by to get this? That would be negative 3x. Okay, so then we multiply. You get negative 3x squared. You also get negative 6x. Parentheses. Subtract, break it up. Cancels. Kind of interesting here though. These become a positive, which cancel with the negative there. Okay, distributes over. You get a positive 6. Positive 6 and positive 4 is going to give you positive 10. You get 10x. We're going to drop the next term. We got a minus 10 there. Repeat the process. We're going to multiply x by 10 to get 10x. So we do that. And multiply here to get 20. Parentheses, separate, cancels, distributes, you get negative 20, you get negative 30. So the answer here will be x squared minus 3x plus 10 plus a remainder that will be negative 30 over x plus 2. And yes, you do have the option to move that negative out front. You could write it this way. That would be an option. Both of those are good answers. However, in a later problem, we're going to see that the top is going to be a binomial. In that case, I would not move the negative out to the front. It's easier just to keep it in the top. Examples 3 and 4, they are going to show us the catch. There's always a catch to something, right? The catch here is if you skip over any degrees, if your dividend skips over any degrees, or even if your divisor skips over any degrees, what you need to do is add in a filler number. And all that is going to be writing in a term that would be missing, but giving it a coefficient of 0. By giving it a coefficient of 0, it essentially doesn't exist. But the important part is that it's going to keep everything lined up as you go through the problem. So let's take a look at the last example that we did. If you look real close here, you're going to notice that everything here is cubed. Everything here is squared. Everything here is linear. Everything here is constant. Okay, everything is organized very nicely. If you didn't have a squared term and you moved that linear term here, then everything underneath it would be out of whack. You would not be able to group those terms. If you had a linear term over a quadratic, it just wouldn't match up. So all we're going to do is plug in that spot with a 0 so that everything stays in line. It's super easy. It doesn't make anything complicated. In fact, it just makes it easier. All right, so for example 3, the dividend, what we start with here is quartic, degree 4. And if it's degree 4, we want it to have 5 terms. We want to have a term for every degree plus the constant. We have 1, 2, 3, 4 terms. That means somebody's missing. Okay? The one that's missing is going to be that quadratic term. You've got 4, you've got 3, there is no x squared, you've got x and your constant. Okay, so we're going to add in a 0 x squared just to space everything out. Okay, so it just goes here, and that's it. And it's only going to space things out, that's all. Here's our box. The divisor's a little bit bigger. Okay, you'd also want to check the divisor, see if we skip over anything. We have a quadratic, then we have the linear, then we have the constant. Nothing was skipped, so that one's good. Okay, the process is still the same. What do we multiply x squared by to get 3x to the 4th? And that would be 3x squared. Now we're going to multiply that to all of the terms that we have here. Your 3x to the 4th. You're also going to get a negative 9x cubed. You're also going to get a positive 15x squared. We're going to add parentheses, subtraction, break it up. These will cancel. We pay attention to the rest. It distributes. You get a positive 9 with a negative 5. That'll give you a positive 4x cubed. Distribute here. You get negative 15 plus 0 is still negative 15. Okay, it does not make it difficult. It's just going to keep everything lined up. We'll drop the next term. Repeat the process. X squared times 4x is going to get us this. Okay, so now multiply 4x times x squared, 4x cubed, multiply. You get negative 12x squared, multiply. You get positive 20x. Parentheses, subtract, break it up. Cancels, distribute. You get positive 12 with a negative 15, gives you negative 3x squared. Distribute, negative 20, positive 4 is negative 16. And we have one more term to drop. That means that we're going to have one more cycle to go through. X squared times negative 3 is going to give us this. Negative 3 times negative 3x will be positive 9x. Negative 3 times 5, you get negative 15. Parentheses, subtract, separate, cancels, distribute. We're going to get negative 9 and a negative 16, which is negative 25x. Distribute, positive 15 minus 6 is going to be a positive 9. And that is our remainder. We can't go any further, right? You can't multiply x squared by anything to create a linear term. In fact, even when you look at the top, we've run out of numbers. We're at our constant. So this will be our remainder. The answer will be 3x squared plus 4x minus 3 plus, we'll do negative 25x plus 9 over the divisor. And for this, I would go ahead and leave the negative there. If you move the negative out front, you're also going to have to change the sign that you have here, which is an option. You could do that. So you could have a minus, you could have a positive 25x and a minus 9. That would work, but I would rather just leave it like this. Let's go ahead and do one more example. Here's our dividend. It's quartic. That means we want it to have 5 terms. We've got 1, 2, 3, 4, so we're missing one. And like the last, we happen to be missing the quadratic term. Okay, we don't have an x squared in the middle here. So we're gonna write 2x to the 4th plus x cubed plus 0 x squared. We're gonna fill that in. Divisor's gonna go outside. That also doesn't skip any terms. And we go through the process. What do we multiply x squared by to get 2x to the 4th? That would be 2x squared. So we multiply. And we get 2x to the 4th. 2x squared times positive 2x is going to give us 4x cubed. We'll also multiply here. We get negative 2x squared. Parentheses, subtract, break it up. It's going to cancel. We're going to distribute. That'll be a negative 4 with a positive 1. So we get negative 3x cubed. This will become positive. With the 0, just stays positive 2x squared. We'll drop down the positive x. Repeat the process. We multiply x squared by negative 3x to get this. We'll then multiply negative 3x each of the other terms. We get negative 6x squared and a positive 3x. Cancels. We'll distribute. You get positive 6 with 2. 8x squared. Distribute. You get negative 3 with 1. That's going to give you negative 2x. We got one last term to drop down. Repeat the process. X squared times 8 will give us this. 8 times 2x, 16x. You also get negative 8. Parentheses, subtract, break it up. Cancels, distributes. We get negative 16 with negative 2, which is negative 18x. Distribute, you get positive 8 minus 1 gives you 7. That'll be our remainder. And the overall answer, I think I'll have to write it over here where I got space, is going to be 2x squared minus 3x plus 8 plus negative 18x plus 7 over the divisor. And I barely got that to fit in there, but that's the answer.
Wait, there was.